let's get into the big topic of open source, something that we actually say at Red Hat.
We haven't
This is so
we
awesome.
are an open culture that believes
actually
in
a big
importance of
piece
What is that process that a developer, or let's say a
As the
developer
Kubernetes
should go through?
ecosystem really boomed,
Hello and welcome to this week's Ask an OpenShift Admin Office Hours. I am Andrew Sullivan, joined as always, and well, usually it's Jonny without me, but joined as always by Mr. Jonny Rickard. How are you, Jonny?
I'm good, man. I'm hanging in there. Trying to, anyways. How about you?
If I had a tail, I'd be wagging it. It's a good day. It's beautiful weather outside. We are less than 2 weeks away from Summit, so it's things are getting easier.
Building up to wind down, right? Like the end is near.
Yeah, I'd love to say that that's true, but it's Summit is the end of this sprint, if you will, in the marathon. So going into June and July, we've got a bunch of other stuff on the docket to keep going. But yeah, the last month or so, and I'm not complaining. Like I like being busy because it means that we're hopefully doing the right things. But like we've had a bunch of analyst requests come in. We've had a bunch of Summit stuff happening. We've had a bunch of just a lot of stuff happening, and it's like my whole team is running flat out right now, and I'm super proud of them. Super happy for all the stuff that they've been working on, and they're doing great work and all that. But
Nice.
like I'm anxious to get for things to go from 110% back down to the normal like 90%, so that way we have a little bit of breathing room. Yeah.
Yeah. So you don't want to burn out, right? Like because eventually that pace is hard.
Exactly, right. And it's important to have that little bit of downtime, right? And like I try and make a big deal out of like having that 10 to 20% of, I don't want to call it personal time, but it's like time to do things for like, oh, I want to go to this training course, or I need to spend time and I want to learn how to do this thing, how to leverage Gemini or Notebook LM in order to do things, or I want to pursue this passion project on the side and figure out how to do, this other thing, or I want to work on a certification. Like, if people don't have time to do that, then, it's to your point, you get burnout. You feel overwhelmed all the time. You feel like you're constantly underwater and you can't ever get ahead. And that's not fun.
Yeah.
So,
Yeah. We have a new guy, and yeah, I saw him committing at like 1:30 in the morning, and I was like, hey, I'm glad that you're doing that. Like I appreciate that you're doing that, but let's not make that the norm. Like like 1:30 in the morning, that's your time. That's Netflix time. That's that's time to decompress and get to sleep and stuff like that.
yeah,
So
yeah. My team spans the globe.
Mhm.
Literally, the sun never sets on my team. So, I try and take the approach of like your work hours are your work hours. Like if you wake up at 5 a.m. and you're feeling energized and like you want to write some code, by all means. But like make sure that you take time, maybe work from 5 to 7 and have breakfast with your partner, or take the kids to school, or go to the gym and work from 10 to 1 or 2, and then have lunch and go for a walk. And like I've known people throughout my career who they still only work 8 hours a day. They just spread it out throughout the entire day, so that way they can live their life during the day as well.
Yeah. I've actually gotten a lot better about that. I used to just grind because you know how it was back in the day. Contracting, you had set hours and stuff like that. Like
Oh, yeah.
you were supposed to work within that grouping, and so it would just be a constant grind. And so
Yeah.
now what I've done, or what I do, is I basically split my day up, right? Where like I'll do some stuff in the morning, take the kids to school, hang out, come back, feed the dogs, do breakfast, all that stuff, and then work for a little bit. And it's nice to be able to split it up and take breaks and stuff like that, because
Yeah.
I'm not focused all the time. Obviously, like if you've been around me for any amount of time, you know that.
Well, it's COVID and the whole work from home thing, I think, exacerbated burnout for a lot of people, because I think a lot of us assume that everyone is tied to their desk for 8 hours a day doing
Yeah.
the things that they're supposed to be doing. And then you see people who are doing things at different hours and stuff like that. And you forget that like those people are probably doing other things during the day. And you think, in an office, like I worked in an office for 15 plus years.
Mhm.
Like you get there at 8:30, 9 o'clock in the morning, and the person in the cubicle next to you wants to chat about what they had for dinner last night, and some rando does a drive-by, and you spend 45 minutes talking about the proper height to mow your grass, and you go to lunch and you spend 45 minutes sitting in the cafeteria, kind of BSing and catching up on things. Maybe it's work related, maybe it's not, but yeah, you might be in the office for 8 hours, but you're only working for 5 or maybe 6 of those.
Right.
And people forget that when you're at home. You assume that the people on the other end of that Slack channel or Teams chat or whatever are working 100%, all out all day long.
Mm-hmm.
And then you give yourself a guilt trip, and then you feel like you should be doing that. And then you're, doing more and more hours and stuff like that. And I don't know, I've been trying to make over the last couple of years, I try and make a point of like telling my folks like, hey, I got an appointment this afternoon, so I'll be mobile if you need anything, but I'll catch up later on. Just to remind folks like, hey, take a break, like live your life. Like, work's not going anywhere. It's okay.
Yep. Yeah, that's how we are. And honestly, my manager, also Andrew, is big on that. Like, he's like, hey, you'll get it, right? You'll get your time. Just don't. It does not have to be all at once. Just when you feel the inspiration, get after it. But yeah, and to Aegis's point, like, I have a quasi routine. Like, I take the kids and pick my daughter up every day. I take my daughter and pick her up every day, and so I try and work in those chunks in between. And then when she comes home, hang out with her and talk a bunch of crap to her for a little bit, and then try and get back to it for a little bit in the evening.
I got a mustache hair that's tickling me like crazy.
Oh yeah, I love those.
Yeah. Aegis, I see here your comment about getting into a routine. I couldn't agree more. Like, I know some people can do that, break up their day and stuff like that, and they spread it all out. I tend to be a routine person, because I found after multiple cycles of like, I accidentally worked 12 or 14 hours today. Like, I tend to start my day around 8:30 every morning, and I tend to end my day between 5:30 and 6 every evening. And like in my office here at home, like you can't see it on the camera, but there's a lamp right here, as well as this thing up here that are on smart switches. So they turn on at 8:30 in the morning, they turn off at 6 o'clock in the evening. And that's my like visual cues of like, hey, stupid, like you're either working too early or working too late. Yeah. So I find that is helpful some days. I end up like, I'm banging away on a keyboard, and all of a sudden it's dark in the room. Like, oh yeah, I should probably go make dinner.
Nice. And honestly, we need that, right? Because like, I know for myself, like sometimes I can get so consumed that like I don't even know what's going on around me. So like I have a little alarm to remind me that it's time to go get Katie, so that way I know like, all right, I need to break away. So
I do that too. I set non-blocking calendar reminders for when I need to go and do things like that.
Yeah.
Anyways, we have successfully completely derailed ourselves for the first 10-ish minutes here. So
yes.
Thank you to our audience for joining us today. Good to see all of y'all, see in air quotes there. Good to see all of y'all. Today's topic is something that is near and dear to my heart. I say that because, one, I've been working with it for quite a while. And two, this is actually what I'll be showing today is a lab that we did at Red Hat 1 back in February, I think. I don't remember when Red Hat 1 was. I think it was in February.
I think so.
Actually, I know it was because I came home. I took a red eye home on Valentine's Day. So it was the week of Valentine's Day.
Nice.
Anyways, so I want to use this opportunity to showcase something that we've been talking about for probably 2 years, Jonny, hosted control planes in various iterations, but I don't think we've ever shown like hosted control planes in OpenShift virtualization in a kind of polished or refined way. And I'm hoping that's one of the things that we can show today, which is like how easy it is to create and manage clusters with OpenShift virtualization, hosting virtual OpenShift clusters on OpenShift virtualization. And my opinion is this is it's a great use case now with the change in the bare metal subscriptions. So if you weren't aware, bare metal subscriptions changed in 2025, where the bare metal, any virtual clusters hosted on bare metal subscribed nodes inherit the subscription. So if I subscribe my bare metal cluster using OpenShift Container Platform, OCP, then if I create virtual OpenShift clusters on top of that bare metal cluster, they inherit their subscriptions from the bare metal. So it's a great way to do, clusters on demand, or even, hey, I want to reduce my VMware footprint, so I'm gonna move my virtual OpenShift clusters from there over to OpenShift on OpenShift. Anyways, I think it's an interesting topic. When we get there here in a few minutes, Jonny, I know you got some top of mind stuff. As always, don't hesitate to ask questions. We love to hear questions, get questions from y'all. Do our best to answer the questions while we're here on the stream. Usually, while I'm running my mouth, Jonny is typing furiously to find answers to questions that we don't know off the top of our head, or I tap dance and give my opinion of an answer while Jonny finds the real answer. There's a lot of that.
We're a team.
Yeah. So don't hesitate to ask questions. If you're not watching us live, please go ahead and reach out to us via email. That's usually the easiest way to get a hold of us. Jonny, Jonny at redhat.com, or Sully, Sully at redhat.com. We are also on the Kubernetes Slack. So if you go to slack.kubernetes.io or kubernetes.slack.com, either one of them will put you in the same place. And there is an OpenShift users channel in the Kubernetes Slack that has Jonny and I and a few thousand other community members that are all there to help answer questions. So with all of my preamble and rambling out of the way, what do we got for top of mind today, Jonny?
Yeah, so Kubernetes 133 was released on, I think it was April 23rd or April 25th. I am going to post it was April 23rd. And so the reason why we didn't announce it sooner is because last week we had the what's next in OpenShift 4.19 PM product management roadmap, live stream, whatever it's called. I can't remember.
Last
There's
week.
so much to it.
What's next is the roadmap. What's new is the what happened in this next release, which is not confusing at all.
Yes. And it was actually really informative. Like first of all, pat on the back. I got the audio right this time, so like everything worked the way it was supposed to. So I was pretty impressed with myself. And then there was just a lot of good things coming out. Like there's a lot of stuff with the UDN stuff. We normally do a recap right after that, but because there were some things that we weren't sure about with the release of the live stream, so we push that to next week. So next week's topic will be a recap of what was in the what's next or what's new. I can't remember what the title was, and I'm just kicking my ass right now. But anyways, with this 133 release of Kubernetes, there are a lot of features that came out. One of the things that I noticed just quickly glancing through the release notes in that blog is that one of the alpha features that's coming out is that they're going to put an RC capability. So think of like a bash RC or ZSH RC, where you can have like environment variables that are unique to you as a user, but don't expose your credentials for the cluster or anything like that. So they'll still map down to your kube config, with that you happen to loop them back into that RC file, which is very, very nice when you're trying to set up an environment. And I think with this, if you're using native Kubernetes, OpenShift does this pretty well out of the box with the namespace or with projects and stuff like that. But this is going to help, I think, with a lot of those variables that we use and stuff. So I think it's going to be cool. And if you want to see all the things that came out in 133, you can go to this link right here. This is the GitHub project. This is all the changelog going into 133. So there's a ton of features that they're working on and that they've put out. So like it's a big commitment on the Kubernetes project, and they're doing an awesome job. And we're consumers and beneficiaries of all the hard work of the community. So make sure you go out there and take a look at it, because it's just freaking amazing that all this stuff can get done in that amount of time. And then finally, we have Argo CD 3.0 released last night, and there's some cool stuff in here. And the big one for me is like there's a change to the RBAC, where now instead of just having like CRUD type of actions on an application, you can actually have that same permission set down into like an actual resource. So within a resource and an application. So you have like your application and maybe a deployment in a pod. Now you can manage those deployments and pods through RBAC in Argo CD. So maybe you have a cluster that you're managing, and you're actually managing access through Argo, which is very typical in production environments, you can actually get down to where that low level permission set is in there, where they can manage like the deletion and updating pods and stuff like that, which I think is pretty cool. And then one of the other things that was in here that I was excited to see is let's see here. I'm sorry, I'm doing this on the fly.
That's just the way life is sometimes, Jonny.
It really is. Oh,
making it up as we go.
Dude, my nickname should be Wing It, because that's what I do half the time. So, there's some defaults that are going to be set out of the box that are going to make life a lot easier for us. And so, oh man, okay, where's the one? Oh, the one that I thought was going to be awesome is like they've implemented a default setting for ignoring differences on high churn controller things. So think about if you've done Cert Manager, or if you've done Let's Encrypt or anything like that, where those things recycle often, right? There's a lot of churn on those resources. A default setting is to ignore those out of the box, so that way you don't have to, when you look at your Argo CD interface, you're not seeing them out of sync and you're having to refresh and stuff like that. So it's just a nice, if you're doing like low level unit testing, or like integration testing and stuff like that, one of the first things that we do in our stuff on on our patterns team is the application healthy and synced? And this will always check in as as a positive yes, because it's going to ignore those differences on this. So I think it's going to be awesome. And that's it. Other than Summit is May 20th through the 22nd in Boston. I'll be there. You're going to be there. It's going to be amazing. Come check it out. We're looking forward to meeting everybody and talking to everybody. And that's it.
Yeah, I will point out, if you're going to be at Summit, as Jonny just said, both of us will be there. Be sure to look out for us. I'll be in and out of the booth. I think I'm staffing the Ask an Expert booth, or desk on Monday and Tuesday evenings or afternoons. So that'll be a great place to find me. You can also reach out to your Red Hat account team. Me, along with a bunch of other BU folks, we're all in the Jiffle tool. So if you want to schedule a customer briefing center CBC meeting with us, definitely encourage you to get that done as soon as possible. I think my calendar is approaching full. So don't hesitate to reach out and request those meetings with us. But of course, you can always run into us in the hallway and say hi and chit chat and stuff like that. From me, when is OpenShift work coming to S390X? S390X, correct me if I'm wrong, is also known as IBM Z and or Linux One. As far as I know, I don't think we're planning support for Power, or excuse me, Z slash S390X, but I can ping the product management team real quick just to confirm that. Let's see. Sorry, I can't type and talk at the same time.
No, I should be talking, but I'm reading all the chat. Just making sure I didn't miss anything.
All right. I know, for anybody who hasn't watched me on the stream before, when I'm like trying to demo something, I cannot. I have to say what my fingers are typing, or type what my mouth is saying. And if I try not to, then it ends up being a jumbled mess. So it is what it is. Yes. I admire people who can do that. I once watched a colleague of mine do a presentation holding a microphone one-handed while presenting the slides, and at the same time logging in, like typing a password with his other hand. It to this day blows my mind. So
not a chance. No way that's happening.
Yeah. All right. As always, please don't hesitate to ask questions here in the chat. We will do our best to address those live. I'm going to try and arrange my windows here so I can see everything that I need to see at the same time, including chat. But apologies if I miss anything as it comes up, but Jonny will keep me honest just in case. So I'm going to share my window here. Share screen, window, with this guy. And what we should be looking at here, I'm going to rearrange this. Actually, how do we want to do this, Jonny? You think that one's a little bit easier to see?
Yeah, I think that's fine. I'll remove your name real quick.
Okay. So what we're looking at here is a ACM instance, or Advanced Cluster Manager instance. And what I have here is just a single cluster that's running inside of my lab. You can see that this one happens to be running on GCP. And what I want to do is I want to use this ACM and this cluster instance in order to deploy my hosted control planes hosted clusters. So if you're not familiar with ACM, ACM is it's a really cool tool in my opinion. It's really powerful. It does a lot of things to make our lives as administrators easier, even though we don't talk about it a whole lot here on the live stream, because it's meant to be like, hey, I have 2 or 5 or 50 or 500 clusters, and I want to use policy and sort of labels to apply those configurations to it. So, right, most of the time here on the stream, we're talking about on an individual cluster, like, hey, I need to go in and I want to configure, the authentication authorization setup inside of here, right? I go to cluster administration and I go to configuration and, I go to OAuth. I should just search for it. So I go to the, OAuth configuration here and I look at this and I see that it's using HT password, right? And, yes, I can go into each one of my clusters and do this. Or yes, I could use something like Ansible Automation Platform to go in and apply this configuration, or GitOps and stuff like that. But depending on the tools that I have and the way that I choose to use these things, using ACM is, of course, one of the ways that I can do that. Right. So I can take that authentication configuration that I have right there, and I can put it in as a set of policies to be applied to my clusters. Right, so I create a policy, and maybe this one is my auth policy, and we're just going to put it in default for the moment because I'm not actually going to create this. But basically, you can see it goes through, and using this template engine, using the policy rules, I can apply in either an inform or an enforce remediation state configuration across my clusters. So super powerful in that respect. My opinion, right? It serves it meets the needs of most things across cluster fleet management in that regard. Other things that ACM can do. So if I look up here in my cluster infrastructure, I can use ACM for doing cluster deployment and cluster level scaling and stuff like that. So we're actually going to use this to create a cluster here in a moment. But I can use this for both hyperscaler, cloud-based, as well as on-prem cloud provider. So think vSphere, think OpenStack, et cetera, deployments, as well as bare metal deployments, which is really cool. So if I come here to this host inventory, so I've got a cluster deployed, let's say hypothetically, I've got a cluster, my first cluster deployed in my data center. I install ACM to that, and then I can come here and I can say, oh, I need to create a cluster inventory. Well, now I'm going to mess it up. Create inventory. Okay, this is probably going to fail because I don't think I have enough configuration there. So I'm not going to do that in the interest of keeping my cluster operational. Anyways, basically what I'm doing is I'm creating an infrastructure environment. So say data center A or server closet 1 or whatever that happens to be. And then I can have within each one of those, I'm going to say data centers, I can go in and I can generate an ISO and then boot nodes, right? I boot my server, be it physical or virtual, to that ISO, and it pops into my inventory here. And then I can go from there and I can say, I want to take these 6 nodes and I want to create a new cluster. And so I can generate clusters that way as well. Or I can take a node and say, hey, I want to join this node to cluster 7, so on and so forth. So really powerful in that regard as well. You'll see that they're expanding in ACM to include a lot more virtualization stuff for doing management and all of that other stuff. There's also ACM does a great job, and I meant to open the dashboard for it. Networking routes. There is a dashboard. No, I don't remember the name of it.
Is it observability or something? I can't remember.
Let's see. We want open cluster management routes. No. Anyways, somewhere in here, I should have brought it up beforehand, is the Grafana dashboard for ACM. So one of the other things that ACM does is it provides federated dashboards for performance statistics, capacity planning, right? All of that type of stuff. So if I have, again, 2, 5, 10, 50, 500 clusters, it uses Thanos to reach out to each one of those clusters and query metrics and pull them in and then provide summarized dashboards. And now I feel embarrassed that I can't even find the thing. What do I want? I want workloads, pods, cert manager, cloud controller. I know it's got to be in here somewhere. Open cluster management hub, routes. Here we go. I'm not looking at the chat. If one of the ACM people is on, they're probably yelling at their screen right now.
What the hell? No. Yeah, I was actually looking at Slack too to see if Brad was yelling at us.
Why can I not find this thing? Anyways, somewhere inside of my routes that I should have brought up beforehand is the ACM Grafana dashboard. I promise it's there. Maybe in the background, I'll see if I can find out where it's at. But anyways, so let's circle back around and allow me to refocus. So inside of ACM, I've got my cluster inside of here. We have also pre-deployed the parts needed for hosted control planes. So in particular, when I go here and I look at the, let's see, I want to look at local cluster and I want to look at add-ons, and I have the HyperShift add-on that's added in here. So HyperShift is the project name for hosted control planes. Hosted control planes is the product name or the feature name for HyperShift within ACM. So we've got the HyperShift add-on inside of here. MCE or multi-cluster engine is available by default with all of the OpenShift subscriptions. So one thing to note about hosted control planes is you don't need ACM to do hosted control planes. You can do it without ACM, but ACM makes it dramatically easier from a management and kind of scalability perspective. So just keep that in mind. The other thing to note inside of my cluster here is I do have OpenShift virtualization installed. So you see I've got OpenShift virtualization operator right here. And I don't have any virtual machines running at the moment, but that'll change here soon. So let's deploy a hosted cluster. So one, I'm going to go up here to create a cluster. I'm going to create this cluster on Red Hat OpenShift virtualization. It is a hosted cluster. So that means that we're going to use hosted control planes. So hosted control planes, and I'm going to walk through this and show you what it looks like on the back end in a moment, is, if you're not familiar with it, it is decoupling the control plane workload from the cluster that uses that control plane. So typically when we deploy an OpenShift cluster, I have my 3 control plane nodes that are hosting all of the control plane workloads. Sometimes they're also schedulable. Sometimes they're also infra nodes, right? So on and so forth. But in this instance, we're taking all of that control plane workload, etcd, the API servers, etc., and we're hosting it in a different cluster. So the control plane is just pods, right? If I were to look at this underlying cluster, if I look at the control plane nodes, everything on there is running as a pod. So HCP takes that and just puts it somewhere else. So go with our hosted cluster. I'm going to use the built-in secret here. I'm going to give it a name. Let's see, what's the name that my lab guide suggests I use? So we'll go with my-hosted-cluster. Right. Cluster set is useful if I have a group of clusters that are all similarly configured, or if I want to do things like Submariner between them. Release image, I can choose which version of OpenShift I want to deploy into this cluster. So one thing about hosted control planes is it manages the lifecycle of these clusters, including things like upgrades. So as the, I'm going to say hosted super administrator, I can control when updates are applied to those clusters. It's not done from within the cluster. So I'm going to go with 417 just because why not? If I want to specify a different storage class for etcd, I can do that if I so choose. So, for example, we know that etcd needs low latency storage. Maybe I have a storage class that's backed by NVMe disk or something. I can choose that. I'm just going to go with my Ceph RVD one here. And then any additional labels. This is important within ACM because labels are how I have those policies and other rules applied. So basically, the moment the cluster pops into ACM, if I have my labels identified here, it'll begin pushing policy down to that cluster. After that, I need to identify my node pools. So HCP, Hosted Control Planes, uses Cluster API to manage the members, the compute nodes associated with that cluster. So Machine API is what has historically been used by machine pools within an OpenShift cluster. However, we're slowly making the move over towards Cluster API for sort of all of those Machine API things. I don't think it has been fully changed over. I think there's still a few platforms that aren't there, but for sure, Hosted Control Planes was the first one to use Cluster API, and all of the node pool offerings use Cluster API.
And that's important to note, just because if you're doing like an OC get machine sets, right? If you're trying to see which ones are out there, you literally have to search for the right API group, like the XKates, like the Cluster API scope. Otherwise, you'll get no return on on your machine sets if you're looking.
Yeah.
Same thing with machines. Anything that was in the machine API, like that's, you have to use the fully qualified API name.
Yep. Let's see. Let me catch up on chat real quick. How does one go about offering OpenShift clusters as a cloud service? I think Hosted Control Planes is certainly one offering or one way that you could do that. Aside from that, like if you're thinking CCSP type of offering or similar, using ACM and Hosted Control Planes is one way to do it. I think it's a relatively straightforward way, but keep in mind that Hosted Control Planes means that more than one control plane is hosted within that cluster. Some people don't like that. They view it as being a security vulnerability. I think that that's a matter of opinion. I'm sure that some security person out there can give me reasons as to why, but I look at it as, if you trust containers and OpenShift and RCOS and RHEL to provide isolation using things like SE Linux and just how containers work with C groups, then why isn't that good enough? Why do you need that extra separation of a virtual machine? For some people, they want full-on separation. For some people, Hosted Control Planes is enough. Beyond that, the cloud-based offering, in my opinion, is mostly about the UX. Right? How do I go in and request a new cluster? What's the process for that? What's the automation behind the scenes, and how does that, basically deploy, prepare, and hand over that cluster over to my customers in those instances? So I don't specifically have a good answer there. I know that Red Hat has a CCSP team that kind of specializes in these things. So, they might be able to offer some other things, but inside of an organization, if it's all folks you trust by and large, then Hosted Control Planes, in my opinion, is a great option.
I read that so literal. I mean, I literally didn't even consider. I was like, I thought that he was asking like how do I set up a ROSA environment?
Oh,
how do I create and manage my own ROSA-like environment for my users? That's from a business perspective, I guess, is where I was reading that from. I was like, oh, I have no idea. Yes.
Which you could do that as well. Like so self-service for these, you could absolutely do that. There's a few demos that are floating around, maybe even on interact.redhat.com. There's some interactive demos that show using Developer Hub to do exactly that. Right. So I use Developer Hub to go in and request a new cluster, and behind the scenes, it takes care of everything for me, so that as the user, I don't know and care about all of the, low level, details. I just click the button and I get my cluster. Is there a hardware list that provides a list of recommended hardware for bare metal installs? Yes, it is the same as the RHEL hardware list. Excuse my hiccup. So OpenShift uses Red Hat Enterprise Linux Core OS as the underlying operating system. Red Hat Enterprise Linux Core OS, or RCOS as the name implies, is RHEL, just optimized for containers and Kubernetes. So it's literally the exact same RHEL kernel, RHEL binaries, everything else. It just uses RPM OS tree and has the kubelet and everything pre-installed there. So if you go to, and I can actually show this, so RHEL hardware catalog. If I go to Red Hat certified hardware, and then I come down here and I click on system, I can go from here and I can look at, all of these different server offerings that are inside of here. So this one's at the top. So we'll look at this DL345 Gen 11 from HPE. If I select this, you'll see certifications and you'll see a number of different things in this list here. So the important one to pay attention to is Red Hat Enterprise Linux 9. So this is the only one that is required for support with OpenShift. So because current versions of OpenShift are based off of RHEL 9, so therefore we want to make sure that it has that RHEL 9 certification. Now, depending on what this hardware partner has chosen to do with their testing, you may also see some other certifications here. So for example, you see OpenShift Container Platform 4.13 and plus, 4.12, etc. What that means is that they went through and they deployed this hardware using bare metal IPI. So effectively, because they did bare metal IPI, they have this checkbox in their certification, meaning that it will work and it is fully supported with IPI. The other one that you may see, and I don't see it on this particular one, there's Red Hat Virtualization, but that no longer really applies. You may see an OpenShift virtualization line item here. What that means is that when they did their certification, they added the OpenShift virtualization operator and were able to deploy virtual machines with this particular hardware there. So that's kind of the full bevy of those. But keep in mind that this is really the one that we care about. The others are nice to know, and it kind of gives you that added assurance that, yes, it's been tested and it should work without any drama. But this is the one that all of that support is predicated on. Let's see, Lenovo, Dell, HP. Yep, they're all there. It's this big old catalog of things here. I can put this in the, if I can find the right buttons, I can put this in the chat. Price list for bare metal subscriptions. I have no idea what the prices are. I work for the BU, so I don't. The sales folks, the account teams are the ones who know prices of things. When I get brought into conversations and people ask me that, my typical, tongue-in-cheek response is, I don't know. It's all free to me because, I'm in the BU. I just subscribe things and it works with my employee account. So
Yep.
I'll have to ask your account team about costs. So node pools. So node pools are how we define the compute nodes that are associated with our cluster. So what's going to happen, right? On the previous instance, I defined my cluster details. So what's the cluster name, etc. And what will happen when we go and create this cluster is it will deploy the control plane, and then we use node pools to define what is effectively the same thing as a machine pool. So this is how we associate compute nodes with our hosted cluster. And because you notice it's not asking me like, what's the provider for these? It's because remember at the very beginning, we selected that this was an OpenShift virtualization cluster. So a few things to note here, right? I just have my node pool. You can create more than one node pool if you want. So for example, if I have, maybe multiple OpenShift virtualization clusters available to me, if I have, different characteristics that I want to have, I want one node pool that is just standard generic compute nodes. And then I have another node pool that has GPU attached virtual machines, right? I can do all of that. Auto repair, if we hover over this, it tells you that it will automatically repair nodes using machine health checks, which basically means if the virtual machine fails machine health checks, it will automatically go in and remove that node and replace it with a new one. And then the root node options. So this one is where I can set the size of the OS disk for my underlying virtual machines, along with if I want to use a specific storage class, etc. when I'm creating those. So I'm going to leave these as is. I don't need to change anything there. And click next. It gives me a nice summary. Then I'm going to click create. Oh, why is namespaces clusters not there? That's probably because I think I need to. Alan, you're probably listening and you're probably laughing at me because I thought that I could just skip ahead in my lab guide and not actually follow the directions that are in here. And this is after Alan and I were just talking about how like you have to follow the lab guides when you're doing these things.
Did you install multi-cluster engine?
Yeah, it should all be in this.
Okay.
One. Yeah. True to point up here. Step 12 is click the. Let's see. We want to go to local. Let's see. We want to go to local cluster, and we want to go to projects, create project, and we need one called clusters. So what this clusters namespace or project is this is the one that will hold the objects for our created clusters. I'll show you what that looks like. Yeah, see, Alan, it is a lab step. I know. Oh, and now it says it already exists. All right. Are you just messing with me here? Well, now it's just messing with me. All of these objects already exist. Clusters, workloads. See, I preach all day long about. Okay, thank you, Alan. Good to know. Preach all day long about following directions, and here I'm terrible at it myself.
The worst, yeah.
No. Let's see. Apologies if I do a lot of switching back and forth on y'all. Well, I'll explore around a moment and find out what's going on here. Projects. So I want hosted. So there's this clusters, my hosted cluster. What's going on in here? Oh, look, it's provisioning things. So it appears that even though it failed over here, it's actually going forward. Yep. Okay. Yeah, Alan should see there in the chat here. I'll put it on the screen. Alan is saying is it does create it if it doesn't exist, but it gives the error. So in the lab guide that he wrote, it creates all of those things. And confusingly, you see that I can no longer actually create this through the UI, even though it's been created. So if I switch back over here, so we see, so what's happened here in the background. So if I do OC get hosted cluster -in clusters,
Yep.
You see I have my hosted cluster object inside of here. So this is why I needed that clusters namespace to exist so that it could create that object. And then what happens is the operator then creates this other project, which is the clusters - my hosted cluster. And this namespace is where it is now when it's not being difficult, where it is now going through and provisioning, deploying all of those control plane workloads. So if I come down here to pods, I go to my clusters, my hosted cluster, you can see here is all of my pods being deployed. Here's my 3 etcd instances. Here's Kube API server instances. Right? The scheduler is inside of here, OpenShift API server, right? The control plane is deploying. And it's continuing to spin up things as we go that are all control plane related. So if we look inside of here, we will also see, so you get node pool -a, because I don't remember what namespace it puts it in.
It's in clusters, yeah.
Yeah, it's in clusters. So I have my node pool that I created there as well. And rather than looking at these on the CLI, I'm going to look at them through the GUI. Node pool. So here's my node pool. And if I look at the object definition on this, you see these are all of the things that relate to the node pool that we created, right? Remember we said 2 cores, 8 gigabytes of memory, 32 gigabyte disk, and then there are 2 of them that exist inside of there. And if I switch over back to my local cluster, well, I was already on the local cluster. If I switch back to the virtualization side, what we should see is node pool VMs provisioning. So this is my node pool VM that is getting stood up. So behind the scenes, we're seeing a number of different things that are all just happening magically based off of the requirements that I created. Let's see, why are you stuck in provisioning?
And the cool thing too is like if you're using AWS, right, and that's my main experience, you can do like an OC get AWS machines -A, and then you can actually see like the provisioned resources and their state. So if they're running or if they're stopped or if like maybe there's some configuration error or something like that. So just another level of debugging. It's pretty
Yep.
cool where you can go in and actually look at the resource and see what the cluster API is actually provisioning and how it's looking at it.
Yep. And so I'll point out a few things here. So let's go back to all clusters. So one, you see that my hosted cluster is in the process of being deployed, right? ACM is already aware of it and already has it's collecting information as it's going through and deploying and stuff like that. We'll see if, as Ellen pointed out, 417 was not working correctly. So we'll see if this works or not, but it is trying its best to deploy. This is also where I'm going to see things like the credentials associated with my cluster once it gets provisioned. So if I come down here, like here's my, kubadmin username and password. So a couple of things to note about this. One, you'll notice that I did not create any DNS entries, load balancer, etc. for this hosted cluster. And that's because the OpenShift virtualization cluster and hosted control planes takes care of all of that for me. So if you look at the console URL here, right, and I'll see, I can't really highlight it, but it is a domain that is hosted underneath my hosting cluster's domain. So I've got this Red Hat workshops.io URL, and then I have the cluster-t6tnt is my demo.redhat.com instance. And then under here, so this is my apps.cluster name for the hosting cluster. And then I have my hosted cluster, which is the name of the hosted cluster I created. And then I have an apps subdomain for that. So apps.myhosted cluster, and then the normal console URL from there. So it abstracts all of that away so that I don't have to worry about when I'm provisioning those. I don't have to worry about external things. It just uses the service paradigm inside of the hosting cluster and routes in order to get everything to where it needs to go correctly and properly. So dramatically easier in that regard when I need to stand up those things. And then you also notice it does have a cluster API address, which is in this instance, it is a IP address. You can override that in the configuration if you want to use a DNS name. So we'll let this thing go about its merry way. I'm going to ignore that for now since it seems to have passed that. Welcome to our virtual machines. So my VMs have been provisioned and are in the process of deploying. So basically at this point, we're waiting on machine config to go and apply the configuration for this cluster. So a couple of things to note when looking at this cluster. If I were to try and go to my console URL at this moment, it's not going to be reachable. And that's because the console and the ingress controllers run on those virtual compute nodes. So even though the control plane is up and running, until those compute nodes come online, at least 2 compute nodes come online, then my ingress and my console are not going to be available for my hosted cluster.
Yeah, and your hosted cluster could be actually like it'll say the control plane's provisioned and stuff like that. It's waiting for the node pool to finish its provisioning and checking in. There's like, I think it's this, it's the history status marker under status that it's waiting for it to be completed. Where when it finally says like, hey, I'm completely done. It takes like in AWS it takes like 15 minutes, if that.
Yeah, we can see that this one is. That one's got a good green check mark, so that's good. So see no nodes appear because they haven't fully joined the cluster yet. So we're still waiting on those to provision. I don't know if that's ifong or lfong. Created a virtual machine on OpenShift virtualization. Want to know how using the VM to connect to the internet. So the easiest way to do that is if you have it connected to which should be the default, connected to the SDN. So here, let's get rid of that. Let's create a project. We'll call this AOA for Ask an OpenShift Admin. I'm going to create a virtual machine in here. I'm going to use an instance type because it's the easiest way. I'm going to create a RHEL 9 virtual machine. I'm going to use the U1 small instance type. And then down here, I'm going to click Customize. So on the network settings, by default, every cluster will have this pod network available to it. Effectively, what this does is it puts the virtual machine on the OpenShift cluster SDN and then just NATs it out to the world. So it'll have direct access, or indirect, I should say, access to the internet from here. If you want to connect it to, for example, a VLAN or something like that, then it gets a little bit different depending on what you want to do. So there is a blog post that I need to find. I need to just bookmark the link at this point. So there's a blog post right here. So this is written by Matt Sekar, who is one of our amazing TAMs, that walks through a couple of different ways that you can connect a virtual machine more directly to the internet or to your network. So the first example, which is the one that I'm going to show here in a moment, is by connecting that virtual machine to the same underlying resources that the SDN is using. So what does that actually mean? So if I come here and look at, we don't have nm state installed. All right, let's install nm state. First, we need nm state.
Hey, and Andrew, real quick, Alan just said that another issue that he ran into last week with 417 was that the node pool gets stuck in updating. So it may not ever update, even though everything's good to go.
Okay. Thank you.
Yep.
So the first thing we need is nm state. So nm state is the operator that is used to configure host level networking. So configuring Ethernet adapters, bonds, bridges, stuff like that at the host level is all done using nm state. And then we connect our virtual machines into those host level networking constructs using Multis, and specifically the network attachment definition CRDs. All right, so deployed the operator. So now we need to create an instance. I don't need to change anything here. And then once that deploys, the console is going to alert me that there's an update and I'll need to refresh it. So we'll give that a second, see what's happening over here. Status is pending. Nope, still hasn't deployed yet. Anyways, maybe this will work, maybe it won't. When I'm ready to, right, up here is my download kubeconfig. So, okay, thank you. When my cluster is deployed and ready, I download the kubeconfig, and then I use that if I'm doing OC or kubectl commands. I have my username and password here. I'm not going to click the reveal because technically this is a internet-facing cluster, but I can see my username and password from here. Here in a moment, I'll show you how to change these things from the hosting cluster level. So one of the big differences with hosted control planes is we move some of the core configuration of that hosted cluster into the CRD, into this hosted cluster object. So we'll walk through how to do that and basically push authentication down to the cluster from at this level. And now that this is done, so in my networking, you see I have a couple of new objects over here. So I have node network state and node network configuration policy. So node network state is what's used to show the current state or the current configuration of my node. And if I click on, let's see, those are control plane nodes. So if I click on a worker node here, it tells me everything that I have here, right? ENS4, I have the BREX OVS bridge, which is the one that is created and used by OVN Kubernetes. And then I have the various OVS interfaces that are used by OVN as well. If you didn't know, in recent versions, we have this little tiny button way up here that'll now give you a graphical representation of that.
Oh, that's dope.
Yeah. So if you didn't know that, yeah, it's it's pretty cool. I like this thing, and I'm getting, I can click on each one of these and I can get information about it and its configuration. They're continuing to make improvements to this. Recently, I found a bug where it had these two things sitting on top of each other, which was very confusing because they're both BRX, but one of them is not like the other, as you can tell by the little icons.
Oh, that's awesome. I love that.
Yeah, so this is telling me, what all of my networking looks like. So basically, if I'll switch back over to here and then zoom in on one of these. So you can see that I've got this one, it put a little bit out of order, but basically BREX is on top of ENS4, and then it is supporting this BREX config, which is actually the one that's being used by OVN Kubernetes. So this is an interface, whereas this is a bridge, even though they're both called BRX. Slightly confusing, but that's the way OVN Kubernetes does it, right? So what I want to do is effectively, I'm going to create a new object that connects into BREX here. And then I'm going to use that to connect my virtual machines so that they have the same connectivity out to the outside world. I don't know how well, I will admit, I've never done this in GCP, so I don't know how well it's going to work, but I'll show you what it looks like. So if we switch over here, all I'm going to do is create a node network configuration policy, and I'm going to just create a new bridge map directly against that existing OVS bridge, BREX. So I'm going to do this through YAML at first, but I'll also show how to do this through the GUI. Yep, don't need to do anything else there. So if I were to do this through the GUI, all I need to do is go create from form, and then I can do things like, I want to create a new Open vSwitch bridge. Well, this one defaults to BR0. Whatever ports I want to put on there, ETH0, ETH1. Or maybe bond 0. I don't need spanning tree protocol, but I do need a vSwitch bridge map because this is what it uses to match the network attachment definition to that underlying bridge device. After that, I can optionally apply node selectors. So if I have 20 nodes in my cluster and 5 of them have a network configuration that uses bond 0 and 10 of them use bond 1 and the other 5 have no bond, right? I would select my nodes appropriately for there. So once we have that connected, so our NNCP is progressing. So once we have that created, I create my network attachment definition. And we're going to connect this to a secondary local net network. So what that means is local net here is referring to a local network device on the host. So remember with that previous network attachment or a node network configuration policy, I created a new bridge map, right? Local network device. And that's what I'm going to connect my virtual machines into. So we'll call this br-local-network. And the bridge map is whatever we called it before, br-ex network. And that needs to match what we created over there. We have the same name. And with that, I can now create a virtual machine, and I'm going to connect it directly to the outside world and hope that I don't break Google in the process of doing this. So I go to network. This time I'm going to edit the configuration and select my bridge network. So that was the one I just created, that network attachment definition I just created. And now when I click create virtual machine, it will be bridged directly into that same network. Let's check on our nodes over here. Yeah, upgrade failing. So to your point, Alan, it did not work on the node pools. Let's see if our console is working. Oh, it is working. Okay.
Yeah, it should be good, yeah.
It just doesn't like the upgrade for some reason. I'm going to pull this out and look at the credentials real quick.
It's funny how, like, I just don't ever use the console. So it's always new to me when I see you going through this stuff. I'm like, I should use this more. I always use the shell.
I flip back and forth, right? So this is our hosted cluster, right? So this is the one that we just created. I come down here to compute. You see I have my 2 nodes. And if I come back up here to my virtual machines in my hosted cluster, so my node pool dash W9 CRC, and then over here I have my node pool dash W9 CRC. So these are the 2 nodes that equate to the node pool over there. You can see that just like if you've ever used EKS or similar, right? Even though I'm logged in as kubeadmin, I don't see a lot inside of here, right? My administration is limited, if you will, in what I can do because some things are controlled at the hosting cluster level. So that's why, like, at the compute, there's only nodes, right? There is no other configuration that I'm able to do inside of here. But a lot of, aside from that, it's an OpenShift cluster, right? I can go in and I can deploy all the normal things that I would deploy inside of here. I can host my applications. I can scale my nodes up and down, although that happens at the parent cluster level.
Yep.
So yeah, lots of stuff. It's a cluster, and I can do all. I feel like I'm being redundant. I can do all the things that I want to do with it.
Yeah. And to your point earlier, like when you were leading into it with the policies and stuff like that, right? Like you can move if you needed to move secrets around, right? You can move secrets around through policies and stuff like that. This is a good example of like where you'd spin up a cluster and then you would assign like maybe you have some label to it, right? That's prod or QA or whatever, right? And then that gets the in ACM it can apply a policy that would deploy an OAuth configuration for QA or for prod or whatever.
Yep.
So maybe in prod you're using GitHub OAuth and in QA you're just using HTTP password. It could push that out, and it's I love those control planes.
Yeah, it's really, I don't know. I like them as well. I know people have concerns in various ways. Usually, the biggest one that comes up is this putting all of my eggs in one basket, right? Meaning that this one cluster, local cluster, now hosts. At a minimum, I'm putting multiple control planes into a single cluster because my compute nodes don't have to be in the same cluster. I can provision virtual machines in a different cluster if I want. I can add or I can have a hosted control plane that uses bare metal servers as its compute nodes and so on and so forth. So, this cluster becomes more critical in that regard. If it goes down, it's going to affect multiple clusters because all of their control plane nodes were hosted here. And if we look, so if we go to hosted control planes, high English is hard. So if I look at this high availability for hosted control planes in the documentation, like it walks through all of these different scenarios and how to mitigate and stuff like that, like how to recover from an unhealthy etcd in one of those hosted clusters, right? Just all of these different scenarios, including backing up and restoring, right? Backing up and restoring a hosted cluster in OpenShift virtualization. And I think what's really interesting is when you think about it, in this model, the hosted control plane is just any workload, and it's just like any other workload inside of that cluster. So that has a couple of important ramifications. One, from a scaling perspective, I don't even have to think about the size of my control plane nodes. So instead, I only care about the size of this hosting cluster. And if my hosted clusters and or hosted control planes need more resources, I just add them to this hosted cluster and it takes care of it for me, right? I don't have to go and figure out, oh, well, I need to resize my control plane nodes. And the only supported way of doing that is to remove a control plane node, provision one of the new size, and then effectively do a disaster recovery on that lost node in order to bring it back into the cluster, right? It handles it all transparently from there.
If I could, I can give an example of that, like a real world, if you don't mind.
Yeah.
We were hosting a workshop in India, and we're using a normal 3-node control plane or a 3-node cluster. We had or 3 compute node, three control planes. And then as we're spinning up clusters, node pools, we started running out of resources because of the number of pods that we're trying to run on the single cluster or per node. So we were able to just literally OC scale the machine sets out And then like that, once we did that, we were able to like it just leveled everything out. And then we were able to deploy like 65 clusters or something like that within like an hour. So it was awesome. And then being able to identify like, okay, look, we're out of resources. Let's just scale this up. And we're able to scale one at a time to kind of figure out like, okay, here's what we actually need. So that way we're not just, OC scale replicas 1,000, putting everything out there.
Yeah. Yeah. I don't know. I find I like this particular process. So, so in behind the scenes here, I'm going to, right. This is another thing I should have done before, which is create the object that I need. So you can't see me. You might hear me typing. But what I'm doing is creating the HT password file that I need for this particular cluster. Because what I want to do is I want to show you how we can push authentication configuration out to this cluster. Yep. Okay.
Is that in the lab guide?
Yeah. Literally copy and pasting commands. I'm just doing it in a terminal window off to the side, so that way I don't give away the credentials.
I just remember HT password dash BBC, whatever it is, and then yeah.
All right. So what I did in the background here, I created an HT password file. So literally all I did was HT password -c -B -lowercase b, and then I added my user with a password inside of there. I then took that HT password file and I added it as a secret to the hosting cluster. So more or less, if you're familiar with over here in the OpenShift documentation, when I look for, where's it at? Configure, I went authentication and authorization, and then, all right, where did you go? User owned identity, understanding identity provider. Nope. Where is HT password? Clearly, I'm still getting used to the new documentation layout. Here we go. Creating an HT password file. Basically, I followed this part of the documentation there for creating an HT. So you see HT password -c -b -b, and then added a user to that, and then not with Windows, and then we created a secret for that. So OC create secret generic using that file. However, I did not do it in the OpenShift config namespace.
Right.
Instead, so this is my hosting cluster. Instead, I created that in my clusters namespace. So you see here's the HT password secret that I just created a moment ago that has the contents of the HT password file. I don't know why that word was so hard to find, or words were so hard to find. So now that I have that secret defined at the hosting cluster, remember this is the cluster where the control plane is running, I go and update the CRD, the configuration for my hosted cluster. So I'm going to come down here to administration, and I want custom resource definitions, and I want hosted cluster, because this is my hosted cluster object. And of course, you don't have to do this through the GUI. I'm just doing it through the GUI because it's the easiest way to show it to folks. And then what I want to do is down here in the spec section where I have the configuration for my control plane, right? This is where I define things like, is this a FIPS cluster, right? What is the base DNS name that it's using for, all of the URLs that are inside of here, right? What's the etcd configuration that it's setting up for it, so on and so forth. So somewhere underneath spec, I'm going to plug in my configuration stanza. So just like you would do, here I'll switch back over to the local cluster. So just like we saw earlier, where I go in here to the OAuth config, and I would plug in this, identity provider thing, right? This is the same thing, right? OAuth, identity providers, HT password, so on and so forth. So with that added in here, I click save. And now behind the scenes, the operator is going to implement that, right? And this is how we get our particular user information to be put in there. So one thing to note, if you did not already record, you notice that it logged me out. If you did not already record the kubeadmin password, it is now lost to you. So sorry. The certificate-based authentication will still work, but basically, just like if you were to remove the default configuration in any other OpenShift cluster, it's also gone from here.
And if you wanted to watch this on your hosting cluster, you could actually go and look in the pods, get the pod status of OpenShift authentication out of clusters-my hosted cluster namespace.
Yep. So now we can log in with my user and the password that we set. And now I'm logged in as just a regular old user, right? So I can switch back over to my administrator. You'll notice that as a regular user, just like with any other OpenShift cluster, I cannot access like the compute side of things and all that. Instead, I'm just deploying my applications. I can create my own projects. RBAC and all of that is managed in the normal way. So I can go in and define my user and cluster roles, or namespace and cluster roles, so on and so forth. So to Alan's point here in chat, I don't think this is going to work when we try and scale our application, but I can certainly attempt. So I can call this AOA-app, app. And then I want to switch over to developer, and I'm going to add, and let's see, all services. So I'm just going to deploy a quick and easy Apache HTTP server inside of here. I don't think I need to change anything here. Doesn't look like it. All right, click create there, and it's going to deploy my Apache application. If I switch back over to the administrator view, I click into my application here and look at workloads. Show me the list of workloads, please. You can see it's going through and it's deploying our pods, right? So our pod is up and running now. So the next thing that we want to do is basically configure autoscaling for our cluster. And again, this is the part where I don't think it's going to work. So back at the hosting cluster, I'm going to modify the hosting cluster's node pool configuration. So custom resource definitions, node pool. And actually, no, I haven't checked. I don't know if this works from inside of here or not.
Scaling?
Yeah, see, I can't manage the node pool there. Oh, it actually says ready now. It finally succeeded. Yeah, so autoscaling is set to false here. Nodes. So it doesn't look like it's going to let me change that node pool configuration from here, which is slightly frustrating. So we'll change it the hard way. So here's my node pool, right? Literally called my node pool. What I'm going to do is change the configuration in here, and I want to do away with this replicas 2, and instead I'm going to add autoscaling with a capital S and set it to min to max 6. And then we click save. It modified itself while I was here. So reload, do away with that and save. Oh, come on, buddy. Don't be difficult. See, there we go. I did my change before the system itself could change.
Feature.
So now, if we come back and look in the ACM side of things, you see it's updated to reflect my new auto scaling configuration of min2 and max6. Right. And if I were to go in and so look at my pods, you can see that I have my pods running inside of here. Switch back to the developer view. If I click on this guy, so let's say actions, I want to edit pod count, and let's bump this up to like 10.
1 million.
So it's going to go through and it's going to deploy, 10 more pods. And what's going to happen is you see there's a bunch of these that are running and or container creating, but there's some that are in the pending status. And that's because what we've done is we've run our 2 nodes out of resources. So if I switch back over here, over here and look at my virtual machines in the right namespace, you see that I now have a 3rd node that is going to get provisioned. This is the one that I created as the example for connecting to the outside world.
Mm-hmm.
Yeah, it looks like it did not get an IP address, which is almost certainly because this is running in GCP, and I don't think it works that way in GCP. But on-prem that would work. Normally, when I show this demo, I use on-prem resources, or not this demo, but OpenShift virtualization demos. I use on-prem resources, and it works exactly the way you would expect. It connects that VM directly to the outside network. So anyways, after a few moments, it'll realize that it needs to auto scale things, and it'll go through and it'll start provisioning the new virtual machine. Sometimes this takes longer than others. When we did this lab at Red Hat 1 with 60 plus people in the room, we accidentally ran Google, the Google region, out of resources more than once. So
it happens often. Yeah, it's pretty funny how often that actually goes down.
How did I not notice that LightSpeed is here? Oh yeah. So it's there, but it's not there. If you have you seen LightSpeed recently, Jonny?
Mm-mm.
Let me see if I can pull it up. Come on, buddy.
Oh, Alan said it's a 5-minute timeout before it initializes the auto scale.
Okay. Well, good. That'll give me a chance to show off LightSpeed. Too many windows open. So I'm going to stop that screen share, and I'm going to replace it with this one. And then I'm going to change the geometry of our screen here. So this is a OpenShift virtualization cluster. It's run by the engineering folks, and I use it sometimes for various demos and stuff like that. So I'm logged in as myself. I'm not an administrator in this cluster. You see that I have a single virtual machine inside of here that is not currently running. So one, with OpenShift LightSpeed, I can ask it all kinds of things. So like, how do I, we'll say, live migrate a virtual machine? And it'll go through and it walks me through the process using the web console, navigate to virtualization virtual machines, right? Select migrate from the menu, right? If you want to do it from the command line, if through the API, so on and so forth. But it also understands like VMware terminology. So how do I vMotion a VM? So
that's cool.
It'll think for a moment, and it'll come back and it'll tell me, you don't vMotion VMs with OpenShift virtualization. You live migrate them. And then it walks through the live migration process. Sometimes it's a little slow.
It's cool though. I mean, so that way you don't have to change the way that you interact with it, right? Yeah, you're not having to talk to it a specific way. That's cool.
Yeah. But the really cool thing that I like, and I'll start this process while this thing is thinking hard. So I'm going to turn on this virtual machine. And you'll notice that it won't start. It says unschedulable. And I don't know why. I have zero desire and zero, cycles to spend on this. So, here it goes. It finally came back. So how do I vMotion, right? In OpenShift, the equivalent of VMware's vMotion is called live migration. So LightSpeed has some awareness of where you're at in the cluster. So down here, I have this attach context. So I can say, I want to attach the YAML and I want to attach the events for this virtual machine and say, why is this VM unschedulable?
You have to set the European way schedulable.
So why is this VM unschedulable, right? So it has awareness of where I'm at when I click the plus, but it doesn't have permissions to actually access those objects, which is why we attach them as the context here. So I attached my information here and basically said, hey, why is this error happening, right? Why am I seeing this? And what it'll do after a moment here is go through and tell me, oh, there's a node label mismatch, right? The VM has a node selector defined as node type. This will fail because I intended for it to fail, right? This label does not match any available nodes in the cluster. So in order to, and you see here, to resolve the unschedulable status, you can update the node selector or you can add tolerations. So it tells me exactly how to fix this. And there was one recently, I should have known better and I shouldn't have deleted the virtual machine. I had created a virtual machine in here and for whatever reason, the disk failed to provision. So it was just stuck in the provisioning state. And so I went in and I said, okay, tell me why this VM is stuck in provisioning. It said, oh, it's because the PVC hasn't created. So I went to the PVC and did the same thing, attached the PVC as context and said, why isn't this PVC provisioning? And it said, oh, because the storage class is reporting this. So I went to the storage class and did the same thing. Why is the storage class reporting this? And it came back and said, oh, because the storage system is reporting this error, blah, 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 and basically walked me through exactly how to fix the error that I was seeing with that. So LightSpeed's getting better and better. Like, this is really exciting to me. Like,
that's awesome.
Yeah, I think it's really neat. I enjoy it. And I like asking it random questions sometimes. So, create a virtual machine connected to the SDN. I like to be polite because, when the machine uprising happens, I don't want to be first.
Dude, I'm always like that. I'm always telling Google, thank you. So.
Somebody told me that there was an article recently about how I think it's OpenAI, the ChatGPT folks, adding in being polite toward it actually costs additional cycles and therefore additional money when it runs its queries.
Good.
Yeah. So anyways, here it's, I gave it a very basic prompt here, right? Clearly you would want to, just like if you've ever seen any of the Ansible LightSpeed prompts, right? The more information you give it, the better it's going to be. So, here it gave me, I said, I just want it to connect to the SDN, and it gave me a very basic definition. And now I can say, the VM needs to have 4 cores and 8 GIB memory. Right. And it's going to do the same thing. It'll come back and it'll iterate and it'll continue to build out the thing that I need until I can go in and just apply it from inside of here. So again, cool stuff in my opinion. I find it helpful.
It's awesome. Enhance.
We've had that conversation before of, I look at all the AI tools. They're exactly as you said, they are an enhancement. They are not a replacement. Mm-hmm. They make it easier for me to do my job faster. Let's see what's happening over here. Clearly 5 minutes is not expired. I don't know why the 5-minute timeout happens. But anyways, eventually it'll time out and we'll get to the point where it is trying to deploy, let's see, 12. Yeah, it should have triggered already. This is probably this is still 417. Alan said that 417 was misbehaving. That's probably why.
Did your node pool numbers go up at all?
I don't
Yeah, like it's
think so.
maybe yeah. Okay, no, it's not doing anything.
Yeah. Anyways, yeah. Oh yeah, that's why right there. Still stuck in the upgrading status.
Yeah.
So, anyways, that's hosted control planes. Destroying virtual or destroying clusters is the same. I can go up here and go to destroy cluster. Detach cluster is a ACM thing.
Mhm.
So it won't like decouple or detach the nodes from the control plane or anything. It just removes this cluster from being managed by ACM. Check for VMs first. No, still not a new VM there. I think it's because it's still in that upgrading status.
Yeah.
I'm almost positive that's what it is. So if I wanted to, right, so upgrade cluster, right, you see I can choose which node pools I want to upgrade. Well, I would be able to if it wasn't already in the process of upgrading. But anyways, I can choose which version I want to upgrade it to. There's upgrades, rollout strategies, which include either upgrade in place or upgrade in place or replace. So upgrade in place is what we know and love from the normal upgrade process. I cordon and drain the node, and then it pushes out a new CoreOS image. Replace basically cordons and drains the virtual machine and then removes it, destroys the virtual machine, and provisions a new one with the new version. Is there anything else? Yeah, the upgrade process isn't going to work. Normally I would demo that, but because it's stuck in this upgrading process for some reason. Let's see, view upgrade details.
Yeah, Alan said that that the 5-minute timeout is there to ensure that the resource pressure exists on the cluster and requires a scale up action. Same thing happens on scale down. It'll wait to make sure that the resource pressure does not return before scaling down on a node.
Yeah,
scaling down a node.
I think that's a tunable. I think we can tune that if I remember correctly. Anyways, I'm no longer logged in as an admin, so it won't tell me what's happening with the upgrade process. But I'm sure I could troubleshoot this if I had. Well, it's already 12:30. So if I had time and I had the right permissions or right credentials. Yeah. Any questions? Anything else I should show off in here, Jonny?
No, I think you did it. The list, if you're curious, there's a config map called supported versions or something like that. I think it's in a clusters namespace, or it might be in local cluster namespace. I can't remember. But it's basically it'll tell you the versions of OpenShift that you can deploy within that hosting cluster. Let's see here.
I don't see it in clusters.
Cluster. Or maybe it's multi-cluster. I might have. It's a thing.
Yeah, I know what you're talking about. It's in here somewhere.
I'm just
stream. It's in the documentation, because in the documentation you can set those to kind of whatever you want. So it'll inherit from when it does the updates, the things that we default it to, but you can of course go in and tune and adjust to set it to whatever you want in your organization.
It's in the HyperShift namespace. Yeah, it's bottom one.
Supported versions.
Yep. Yeah, this is it.
Yeah.
So you can deploy 4.17, 16, 15, 14, and then like when you upgrade your cluster to 4.18 or 4.19 or whatever, and then the version of MCE updates, then that will also update, and then you can roll out to like the next, then you can start deploying like 4.18, 4.19, whatever.
Yeah. Yeah, because this hosting cluster is it's running 4.17.
Mm-hmm.
So, and the hosted cluster versions have some dependency on the hosting cluster version.
Yeah.
So hosted clusters, OpenShift virtualization. I find it to be a straightforward and simple deployment. Two big use cases in my mind. One, Clusters on demand. I have development teams, application teams that need to create clusters, whether they exist for a few hours, a few days, a few months, a few years, right? They're all able to be managed from within inside of there. The other one being, hey, I am the OpenShift grand administrator, right? I'm the administrator over all of the administrators, or the administrator team over all the other administrator teams, and this gives me a way to consolidate and manage all of those things through a single interface and a single set of tools. I'll also point out, so even though we didn't show it in this particular demo instance, you can tier these things out. So here I deployed both the hosting control plane. So if I come here to my workloads and go to pods, and I look in the pod for my, here is my control plane. And then I also have, my virtual machines all running. Oh, there, it's provisioning a new node. So it finally fixed itself. There we go. And I have my compute nodes for my hosted cluster in the same cluster. I don't have to do that. So I could have, in AWS, for example, I have my main management cluster that's running. And then at, data center A and data center 1 and data center, square, I have hosting clusters that are running OpenShift virtualization. So I can deploy from my central management cluster, I create my managed cluster object or hosted cluster object, and I create it targeting that data center square hosting cluster, and it'll instantiate the resources inside of there. And I can even further tier it out. So I could say from my management cluster in AWS, create a control plane in cluster 1 in data center square, and create compute nodes in cluster 2 in data center square. So that way I have like all of these things sort of distributed across all of the different resources that I have available to me. And at that point, this central management cluster becomes my ACM hub for pushing out policies and configuration across all of those. If I'm using GitOps, it can become my, Argo CD host, again, for pushing out configuration and managing configuration across all of those. Thank you, Alan. So, there's just a ton of different ways that I can deploy these and manage these across all the different resources that I have available. Note that tiering out one also helps to distribute like control plane workload and where it's at. So that way I'm not having that, all my eggs in one basket problem.
And another thing to note too, like if you're really like in a pinch and you're trying to drive down your cloud spend, you can have an ARM control plane and then x86 workers and stuff like that. So I mean, like you can really take advantage of like the different CPU architectures and stuff, which is I think is pretty incredible.
Yep. Okay. I think that's all I got. Yep. Now it's going through and doing its thing. Adding our new node, which is now up and running. Hasn't popped in yet, but it'll be there. All right. So that's all I've got to show. If anybody has any questions, please go ahead and get those in the chat now. If you're not watching us live, if you've been listening to us or anything like that, as always, you can reach out to us. Jonny, Jonny at redhat.com, or Sully, Suloy at redhat.com. Happy to answer any questions, put you in contact with, the product management team or the other folks who are responsible for hosted control planes. I know somewhere my team has a document that's like hosted control planes architecture considerations and stuff like that. I don't think it's been published yet, but it's one of the things that we want to get published. Keep an eye out for more stuff that's happening there. And, I know that we here on the stream, this is probably the 4th time that we've talked about hosted control planes. But it's one of those, like, hopefully you're seeing a clear progression in the capabilities and the use cases here. Again, I look at it as, and I feel like this is an easy one for moving my virtual OpenShift clusters from other hypervisors and onto OpenShift natively. And again, with the bare metal subscription changes, it makes a lot of sense in my opinion.
Yeah, we use it for speed of deployment. Honestly, like it makes sense because we're spinning them up and tearing them down multiple times a day.
We keep talking about doing a cluster install live stream again, because it's been a while since we did one. But whenever we do the cluster install live streams, we always have to schedule. Like, I know today we went an hour and a half, but we always have to plan for like 2 hours because deploying clusters takes so long. But you saw I deployed a cluster here in like 10 minutes.
Yeah.
And really, it should have been faster if it weren't for this, upgrade bug that's happening. But Pudak, what can explain the fact that suddenly one of my control plane nodes lost its configured IP and went into not ready state? I mean, most likely it would be something like the VM. I'm assuming it's a VM, but the node is no longer able to connect to the rest of the control plane nodes. So essentially what that's saying is, I'm logged into my OpenShift console and I see this node drop off. I don't see an IP and it's in the not ready state. That means that it's not getting heartbeats and it's not able to contact. So the health check stuff for, I think the default is 5 minutes. At that point, it puts it in a not ready state. If you were to look at that or connect to that node directly, you would see that it has a taint, a no execute taint set on it. So it's actively shutting down workload and stuff like that. I have a basic question from James. Is it possible if a node that is running on a VM fails that the VM can be restarted on another node statefully? Yes, absolutely. So I won't be able to show it in the lab that I have here, but I can reshare this screen. So essentially what happens is virtual machines are like any other workload that's running inside of the cluster. So if my node were to just disappear, it's going to go through the normal progression of things shutting down and restarting. So as I just described with whoever that was, Pudak, and the control plane node, when a node becomes unreachable, it goes into the not ready status. So by default, it takes 5 minutes, 300 seconds for the control plane to deploy a node not ready. At that point, it starts another set of timers for restarting workload that was running on that cluster, or on that node. So with virtualization, we want to take an extra step to fence that particular node. And the reason for that is because persistent volumes. We don't want that cluster node that is, not reporting or not otherwise able to connect to the control plane and therefore get declared not ready to actually still be running our virtual machine workload. And then I restart the virtual machine or I start it again on another node. And now the virtual machine is running in two places and I accidentally corrupt its disk. So we utilize fencing agents in order to do that. So the most basic one is the node self-remediation operator, used to be called the poison pill operator. That will basically, there's an agent on the node that if it is up and running and just network isolated, it'll just reboot that node. So that way it releases all the workload. And then there's an equivalent agent that's still running on the control plane that says, oh, the node went ready, not ready. The node has not responded in 5 minutes. I'm going to wait an additional 60 seconds for it to reboot. And then I'm going to forcefully restart all of the workload. So that's more or less what fencing does. There's other fencing agents. So if I have, if I'm using bare metal machine sets, and I have machine health checks configured, I can use the bare metal operator to reach out and physically interact with the bare metal management controller and restart that physical server. There's all kinds of other stuff there that can happen. So end to end, depending on how you tune and how you adjust the configuration, that high availability restart will take anywhere from about 90 seconds up to like 6 or 7 minutes, depending on which fencing agent you're using and how aggressively you have those checks and timeouts set. The best way to find more information about that is from the KCS. So I don't think I'm logged in. No, I'm not. So there's this fencing and VM high availability guide. So I will paste that link here into the chat. And that'll walk you through all of the different things. Let's see. Thank you, TC. Appreciate your compliment. Upgrades. So I didn't show it because that thing was flailing about as we were going through it. Where's my switch back to the all clusters view here? But in order to upgrade a cluster, you basically use this same interface. So I would click here, right? If it wasn't currently stuck in this upgrading status, I would be able to go in and I would be able to say, I want to update or change the version of my cluster. You can see you have this upgrade cluster. I'll be able to select which version I want it to update to. But again, it's currently broken. And that's just a quirk of my lab. That's not like fundamentally broken.
Mhm.
I think that got all the questions in chat.
Yep.
Okay. All right, Joel. Thank you for joining us. We appreciate all of your questions, all of your inactivity. If you see anything here, if there's anything you have questions about that you want to ask more about, again, don't hesitate to reach out to us. Here we can turn our emails back on here. So you can see our email here on screen. Again, Jonny, Jonny at redhat.com, or Sully, Sully at redhat.com. With that, we're streaming next week, Jonny?
Yeah, we're going to do a recap on the what's next.
Okay. So if you, the what's next presentation is like 90 minutes long, lots of in-depth information in there. So if you missed it, we'll do a recap of it and focus on some things that are important to administrators. But that is the roadmap presentation for OpenShift. The what's new presentation, I don't think it's been scheduled for 4.18 yet, or what's the next version?
19.
4.19.
Yeah.
So I don't know when that'll happen. I assume for sure sometime after Summit, but I don't think too far after Summit. Last thing I've got is just keep an eye on the redhat.com blog. It's probably going to be very noisy over the next few weeks as just a ton of stuff is getting published about Summit and all the happenings that are going on there. I'm pretty close with the OpenShift virtualization stuff. I know that there is a ton, like 20 plus OpenShift virtualization sessions that are happening, as well as a number of customers who are going to be presenting. I think there's 2 in the day 1 keynote that are going to be talking about OpenShift virtualization. So lots of really cool stuff. I haven't seen all of the details for the day 2 keynote, which remember is the more technical one, but what I know of it, it's going to be pretty awesome. I'm really excited.
Nice.
If you've seen me recently, when I sit in the when I'm sitting in the tower, if I'm sitting in the office with the whiteboard behind me, that whiteboard has the flow for the day 2 keynote, the big demo on it. And so I always blur out my video because I don't want to give it away for people or anything like that. But like, I am super excited to see that one come together. I think it's going to be really awesome. Put it this way. It had my boss, who is a vice president, writing Python code. Like,
wow.
I think that's pretty amazing. When we've got a VP who's writing Python code in order to like showcase it and, get things or show capabilities, and just he's that excited about the things that we've got going on, which is
awesome. That is awesome.
Yeah. All right, y'all. I'm going to click around some buttons. Jonny, any last words?
Hey, thanks everybody for all the conversation. It was awesome. Alan, thanks for all your help, and really looking forward to Summit and seeing everybody there.
Yeah, likewise. TC, any homework you can provide? I don't have any homework. If you want to learn more information about hosted control planes, what I would suggest is, so one, this lab that I showed, everything that I walked through, you can reach out to your account team and ask them to give you access to an instance of it. So it's available through at least the end of May, is what I've been told by our HTTP team. So reach out to them and ask for access to the Red Hat 1 hosted control planes lab. To get us ready for the next AOA. No, I don't think so. If you want to watch, if you have time, if you're in the car and want to listen to the roadmap presentation and any questions you've got, you want to bring to the next one, by all means. Other than that, we'll probably find something interesting, because interesting, or at least what Jonny and I think are interesting from a technical perspective. See if we can find something to demo or something like that next week as well.
Yeah.
The roadmap presentation, it's always hard to gauge how long those conversations take. Sometimes we can get through them in like 15 minutes, and sometimes it takes like an hour.
Yeah.
All right, Jonny, I will see you next week. Thank you, everybody. Have a great rest of your week.
See ya.